SOLIDWORKS Plastics Advanced enables you to accurately evaluate the warpage and shrinkage of your design by accounting for cooling lines and the actual mold temperature characteristics during the cooling down phase of the component. Additional setup for the analysis is minimal and intuitive. You additionally specify the mold dimensions and coolant lines along with their material properties. For the coolant lines, you can specify flow direction, the type of liquid, default temperature and flow settings per individual channel if desired. The last step is to specify the cooling process parameters such as the minimum coolant temp. Parameters such as inlet melt and ejection temperatures are automatically updated based on the polymer material chosen for the injection process. You're then ready to run the analysis. Let's take a look at some key result characteristics that are important to your design and that can significantly impact part performance. The cooling time is the time it takes to reach the average ejection temperature, in our case 90 degrees for the polymer we have. Looking at the temperature at the end of the cooling process helps identify areas where the part is still hot. This information aids in making improvements to the mold or cooling layout to avoid production issues. You can use the ISO surface clipping to easily show the volume of material still above 90 degrees. This makes it easy to determine if sufficient material is frozen at the end of the cooling cycle. You can also compare the temperature difference across the part using the measure tool, which aids in validating that the average temperature variation is not excessive. By switching to the mold temperature, we can even evaluate the thermal mismatch to temperatures in the part itself. By highlighting just the coolant channels, you can also identify where most of the heat transfer is occurring by showing the heat flux. Another valuable aspect is to understand the differences between the analysis without accurate mold and cooling. By looking at the predicted flow results, we can review the estimated values based on a uniform mold temperature during cooling. The flow predicted cooling time is very similar to the accurate analysis at just under 19 seconds. The temperature at end of cooling shows more significant difference, with the accurate analysis showing some areas with higher temperatures. This is again due to the assumption of temperatures in the mold being uniform the entire time. Another aspect we can compare are sink marks. The simplified analysis suggests a peak value of 0.08 millimeters. When we switch to the more accurate warp analysis, the sink mark peak is only 0.025 millimeters and over less of the component. This shows a conservative prediction in the simplified analysis. For actual part warpage, we can not only evaluate the final shape, but also the contribution of in-mold residual stress or the quenching process to the warpage. For the accurate analysis, the maximum warpage in the y direction ranges from -0.9 to 0.64 millimeters. By switching to the configuration where warpage is calculated with the uniform mold temperature, we can see how accurate the simplified analysis is. The maximum warpage in the y direction is from -0.5 to 0.73 millimeters, but also with a very different deformation. So we can see the importance of accounting for the detailed mold temperature during the manufacturing process, especially when determining the actual part warpage and sink mark effects. With SOLIDWORKS Plastics Advanced, you can minimize plastics injection design problems or the need for tooling changes in production, saving you time and money.